So one of our customers reached out to us with a very cool application. The customer works in the electronics industry and they're inspecting very small components. The type of components where feature size is in the order of 60 micron. So right now, what they were doing is they've been utilizing microscopes and other means of manual inspection that would take in the order of a day or two to execute a full pack of product. So when they reached out to us, initially we were looking at it from a machine vision perspective is what do we need to be able to inspect these products reliably? The first consideration that the customer wanted to achieve was that we had 100% accuracy on the inspection of the product. And the second one was the footprint. They wanted to keep it a tabletop system so that it could coexist with their existing space that they had available. So Adams took in this project, we looked at the products and we realized there's no way with a single camera we can inspect the field of view that big and also compensate for the different variations in SKUs that they have. So this customer also has products that vary in size and form. So we needed a recipe-based system to adjust for those variations as well. So we created a solution for the customer. We used a very compact industrial arm, a Mecademic 500 arm. That's also a highly repeatable robot. So it's repeatable within 5 micron. So for an application like this where components are this small, it is crucial that we can have a repeatable robot to execute. And then we're using a Cognex camera to be able to meet the inspection requirements of the customer to make sure that 100% of the product gets accounted for and inspected and then passed to their database. So here you see the solution that we have. The field of view on the camera is only a handful of millimeters, it's about 8 to 10 millimeters. As you can see, that's only the area that we're illuminating here to perform the inspection. We need to, of course, move that field of view around the part to be able to compensate for the different size parts that we have.